Now we have Ryan Kelly. This speaker is one of the certified evil geniuses of the Australian Python community. He's currently working on building high-performance web APIs for the Mozilla Services team. And he's going to talk to us about testing for graceful failure. Please welcome Ryan Kelly.
Cool. Thanks for coming out, everyone. Yes, I am here to talk about testing. Now, it is 2013, so I hope I don't need to stand up here and try and tell you all about the virtues of testing your code. Right? Testing and automated testing are one of the best and possibly one of the only ways as professionals that we can build software that works reliably. But the funny thing about testing is that no matter how much of it you do, it's never quite enough. All right? You can have huge volumes of unit tests and 100% branch coverage and a great chunk of integration and functional tests, and you put your code out there in the world where it has to interact with other things, and stuff will still go wrong. So I'm kind of here to talk about how we can poke at the things that go wrong and figure out how our code will cope when they inevitably do. So I'm going to assume that we're actually starting from a very happy place. I assume you have a web application, which is what I do, and you're actually confident that this thing works. You know, you have tests, it does what it's supposed to do. And you've also figured out how you're going to deploy this application into the world and how you're going to check on it to make sure it's still behaving as you intend. Now, for a web project, this is a very happy place to be. Like a lot of projects won't even get to this point. Nonetheless, if your application is really good and you make the front page of Reddit or Hacker News or something, or if you're being cool and deploying into the cloud and your cloud vendor has some sort of network outage, your database goes down, it starts dropping packets to your Memcache instance, stuff like that, you're going to take a hit. Your application's going to start failing. Now, the question is, how gracefully can you cope with these kinds of failures? If you're a really super important code, maybe you want to be sure that your code can stay standing and keep operating even in the face of failures in its environment. If it's less important, maybe you just want to check on that it can do as good a job as it can and maybe take a small hit rather than a big hit. So I come to this field from the Mozilla Services team, where I work with a lot of people who know a great deal more about this stuff than me. We're responsible for running things like the servers behind Firefox Sync, the marketplace app that's going to support the new Firefox phone, and making sure that these services will stay standing in the event of failure. So I'm going to give you a little bit of a demo of some of the processes and tooling that we've built up around doing this. It's not a tutorial. If you're interested in this stuff in more detail, you'll have to read the docs or come and find me afterwards and we'll chat. But I want to give you an idea of the sort of failures I'm interested in. This is a very simplified diagram of the Firefox Sync server. Right? It's a little WSGI application. It takes some data in from Firefox and it dumps it into MySQL. Because we have a fairly large user base, it actually does some app-level sharding. Right? Each user is assigned to a particular database, and the web app is responsible for sending data to the correct place. If one of these databases starts having a problem, or the network goes down and packets aren't getting through, right? According to this diagram, what should happen is that users destined for this particularly unhealthy database will get an error, or they might time out or something. Users destined for these other databases, they should be fine, right? There's no problem there. We should be able to keep going even in the event of this partial failure. Unfortunately, the real world is never as simple as the diagrams would have you believe. And what actually happens is that your web server has this little pool of worker processes inside it. And every time one of these worker processes goes to talk to the database that's having problems, it doesn't come back. And if you have high enough traffic going on all at once and these requests are taking long enough on the back end, you start discovering that all of your workers are disappearing, and eventually the whole system comes crashing down. This actually happened to our code, to our server. That's bad. I wouldn't call that a graceful failure. We haven't done the best that we could do under the circumstances. The thing is, though, like, as they say, is to actually stand up your system in a state that approximates what it's going to look like in production. Here we go. Deploy it in a state that it kind of looks like in production. Put it under the kinds of stresses and loads that it's going to be experiencing in production. And then try and break stuff. Make the environment around your application fail and see what happens. See if you can figure out how it's going to handle those failures. The rest is up to you. So step one, deploy it. And this is going to depend heavily on your own setup. You might be deploying into the cloud. For Firefox Sync, we have some actual physical staging hardware that we deploy our stuff on. And for the purposes of this talk, I've stood up a little demo server, and I'll just show you real quick how it looks using requests, because everybody should be using requests. I'll put in my actual username and password here, so be kind, don't hack me. So I have pyconau.services.mozilla.com. I can go ahead and have a look at the data that I've got synced there. So I have a couple of synced collections. I've got my history, my bookmarks, and so forth. I can make requests to this system and get at all of my synced data. That's our starting point. We have a system standing up that works. Now, what are we going to do? Let's stress it out. Our go-to tool for this has been a tool called FunkLoad, which is basically a functional and load testing tool. It has some nice facilities for writing your test. It has some nice facilities for generating reports. It's a little bit clunky, to be honest, which you might get a sense of when I show you in a minute, but it gets the job done with a minimum of fuss, which is why I'm happy to kind of show it and recommend it as a good place to start. It looks a little bit like this. So the idea is that you create something that looks a lot like a unit test. But it inherits from this FunkLoad test case class. You do the usual routine of setting up and establishing, some sort of common parameters for each test. Here we go, I'll get the URL. And then basically you write a test case that exercises your server in whatever way, you're likely to see in production. So I'm going to do the same thing that I did in requests before, but a little bit more verbosely, because FunkLoad has its own special way of specifying how you should interact with a web API. So you say, all right, I have to say, this is the return code I'm expecting, and I'm going to make this GET request. Right. I'm going to poke around in the response to that and make sure it's okay. I'm going to pick, in this case, a random collection out of what I got back, and I'm going to make another request. So you can imagine me filling this out with a much more thorough simulation of the kind of user behavior that we actually expect in production. As you can tell, I did a 4-year degree in speed typing at the University of Melbourne. This is fake. Yeah. Now I'm going to configure basically how FunkLoad will run this thing. So I give it some metadata, I give it the URL of the server I want to test, and I say, right, I want 3 load test cycles, 10 concurrent users, 20 concurrent users, 30 concurrent users. I want each cycle to run for a whopping 5 seconds, because this is a demonstration and not a real test. And I can configure a bunch of stuff about how it does its logging and so forth. That's it. That little test I can now run with FL run bench, and I can put my demo server under some serious load, like so. In the real world, for the Firefox Sync server, for example, we would run a set of load like this for 24 hours before pushing anything out to production, so that you can uncover kinds of effects that only show up. I've run out of open file descriptors, things like that only show up after you've been running for a long time. But what this is doing is basically playing that test case over and over again in a bunch of concurrent threads. It's collecting all of the statistics, and I can ask it to build it up into a nice little report. Like so. And I'll get something like this. FunkLoad bench report for PyCon AU. And we can already see I haven't actually done anything bad to my application, but it's not looking very healthy once I get up around 30 concurrent users. That's okay, it's only a demo server. But this will tell us things like, this is the number of successful tests per second. This is the number of successful pages per second, which actually looks quite good. This is the latency per request, which actually looks quite bad. So even here I can see actually my application is not handling this code very well. Like the latency is going right up. This could be an indication of some sort of problem. And in fact, it's an indication of the sort of problem I showed you in the Firefox Sync server, where latency gets too big, your workers start to get packed up, and bad things happen. Ideally, you'd be combining this with some sort of server-side monitoring. But this is a good starting point for seeing how your application behaves under load. FunkLoad has a bunch of other cool stuff, like it can run distributed tests from multiple nodes and generate differential reports and all this stuff, but it's kind of clunky. Like the language is very verbose, you have to run it from the command line and automatically manage a bunch of things. So we created this thing called Marteau. Marteau is basically a hosted web front end for running your load tests. It uses what I just showed you in FunkLoad on the back end, but it's got a nice interface. It does things like automatically spinning up worker nodes in AWS, so you don't have to manage a farm of load generating nodes. It has a job queue, so that you don't have 6 people trying to run a different load test on one system at the same time. It can generate reports and save them for you and so forth. It's French for hammer, because the guys that are kind of responsible for these projects are all French. So it's cool they have an easy job making up names for things. Has anyone used the continuous integration service Travis for their tests? So a couple of people. Travis is this really great hosted continuous integration service where you basically create a .travis file in your GitHub repo, and it uses that to detect where your unit tests are, figure out how to run them, and run them for you automatically. Marteau is basically the same idea applied to your load tests. So you create this .marteau.yaml file. You fill it out with some information, like this is my name, this is where the tests live, this is the particular test I want you to run. I want you to run it concurrently on 5 nodes so that I can generate a little bit more load. And when it's all done, I want you to email the report to me here. Commit that into your GitHub repo. Go into the fancy, hopefully loads. I took the clever move of caching this locally, but it still wants to load a bunch of fonts and stuff. Go onto your hosted web, load testing service, put in the URL of your repo here, hit go, and it'll spin up and run your load. If you want to get a little bit more fancy, you can click through and set, I'll run a longer or a shorter test, I'll run it with more nodes and this sort of thing. The idea being to make stressing out your application, putting as much load on as you can, kind of click a button and off you go. To make that something that's really easy to do on a continuous basis against experimental branches, wherever you need to investigate your code. And yeah, it'll keep a log of the things it's done, it'll let you have a look at the reports, and go back and track how your application's been going and things like that. So that's Pyramid app. Getting it up and running can be a little bit fiddly because it uses like Redis and a couple of backend services. So I'm not going to go into details of that. You can ask me about it afterwards, or just catch up on the docs or online. So at this point, we've basically got our application in a position where we can see what it's going to look like live in production. The third step, and I think the most interesting step, is to try and break it. Now you will probably, unless you're very, very good at your job, get this step for free a lot of the time. You'll find you're not closing some resources properly, or you haven't tuned your database properly, or something that means actually your application isn't going to stand up to the kinds of load you thought it would. Once you've got those bugs shaken out, you can start to get a little bit more creative. And I recommend the very first thing you do once you're satisfied with your application that's passing a load test, restart your database in the middle of it. When we tried that on the Firefox Sync server, what we expected to happen was, you restart the database, you get a bunch of errors because your database has gone down, that's fine. The database comes back up and the errors stop. What we actually saw was, we got a bunch of errors, the database came back up, the number of errors reduced, but they didn't go back to 0. And we actually tracked it all the way down to a bug in the SQL Alchemy connection pooling logic, where if there was just a precisely weird series of errors meant that it would leak a connection from the pool. And if you had enough load going on your site at the time when you restarted your database, it would lose a bunch of connections from its pool, you'd be left operating at a reduced capacity, and you would see failures where you weren't expecting to see any. So that's the sort of thing that we're interested in looking at. Once you get a bit of a feel for this sort of thing, it's nice to be able to be a little bit more deliberate about it. At that stage, you want something that lets you reach into your environment and make it fail in very controlled and interesting ways. So that's why we built this tool called Vaurien. Vaurien is essentially a TCP proxy. Right? It sits in between your application and some backend service like MySQL. It takes your data in, it proxies your data back and sends it back forward. What makes Vaurien special is that it's kind of a jerk about it. You can configure it to do interesting things like, insert a delay in between, connecting to the socket and when it hits the back end, when it comes back. You can tell it to just accept your connection and then forget about you and walk away. You can tell it to inject various kinds of error. We've implemented a number of different protocols. So it can speak HTTP, and it can look like a really badly behaved HTTP server. It can speak a little bit of MySQL and look like a badly behaved MySQL server. And the important thing is that it's easily extensible. So behaviors and protocols are pluggable. So if you've got Redis or something, I'll implement some specific error behaviors for Redis. I'll implement some specific protocol handling for Redis. Again, there's French for rapscallion because it misbehaves. And you use it something like this. So I'm going to do the same thing I showed you before with requests and with my demo server. But instead of connecting directly to the server that I'm running, I'm going to start Vaurien. I'm going to tell it to listen locally on port 8000. I'm going to tell it to proxy that to our demo server, PyCon AU services mozilla.org, and I'm going to tell it to speak HTTP. Initially, everything looks the same, right? I can connect to that as if it were the live service. I can do the same requests I was doing before, and I'll get the same results. That's fine. Where it gets interesting is I tell it instead, right, insert this behavior. For 50% of all your requests, I want you to insert a delay. Okay? And we'll see it inserts a delay into some of your requests. Not all of them, but some of them. I might ask it to insert an error into the requests. And because it knows it's speaking HTTP, it'll give you a 502, right? Or a 501 or some sort of HTTP related error. Like that. This is one of my favorite ones, is I can just say, right, 100% of your requests, just hang them. Don't do anything. And it will obligingly accept your connection and do nothing. I can wait for that to time out. This is a good way to test two things, whether you're accidentally catching weird exceptions, and you'd be amazed the number of things that you can't interrupt with a keyboard interrupt if they hang on an open socket. It's also good for checking if your timeouts are working correctly, and fortunately for Kenneth, Request does a very good job of handling these things correctly. So that's one way to use Vaurien. You can get this kind of static behavior on a certain percentage of your requests. I think it's more interesting to actually take control of it on the fly. So I'm going to tell it instead, just listen on a HTTP port, and you'll see it's now listening on port 8080. No behavior is enabled by default, but I can put a request to that local port and say, hey, switch on the error behavior, and it'll start giving me errors. I can say, hey, when I get up to typing it, switch on your hanging behavior, and it'll start hanging. Right? So this gives you the ability to switch on and off particular areas of interest and kind of script test cases around them. If you need to switch them back off again, you can set them to this dummy behavior that does nothing. Now the demo server I've got running there, actually, in between it and the database, I have an instance of Vaurien running on a separate port here. And currently see it's not doing anything. If I switch on the error handler there, it will give me like a MySQL wire protocol level error. Actually, I don't think it's that sophisticated. It currently just gives you gibberish, but you could put in a MySQL protocol level error. If I then try and interact with my web app, we'll see two things. One is that it takes a long time, because the sync server is trying to retry in the face of this error and say, oh, actually, the database is misbehaving, I'll try again. When that comes back, we'll see, oops, there was a server-side error. And if I have a look inside there, I'll see, yep, I just forced my application to generate a crash. So I can then go into my server logs and have a look at exactly how that was behaving. So I think that's pretty cool. And there are two ways that you can go about using this functionality. The first is to basically just switch it on, like I was saying, run a bunch of load against it and see what happens. Right? Switch on a 5% error rate in your database connection and have a look at the error rate coming back from your application. Is it 5%? Is it roughly 5%? Is it 50%? Try and figure out ways that this is misbehaving. That gives you a clue to what you can go in and have a bit of a poke at to see where things are going wrong, where you could be handling these errors a little bit more gracefully. Once you've found those things, you can turn this into a functional test. All right? You can spin up your servers, you can very carefully switch Vaurien on to a specific behavior that you want to test, run a specific set of behaviors in your API, and make sure that it is now handling that correctly. I think I have an example of that from the Vaurien docs here, which is quite nice. You say, you start the proxy. In your test, you say, look, enable this behavior, do a bunch of tests against your API, switch the behavior back off, check that it was doing everything okay. So that's where we're at. And I want to do two kind of take-home messages from here. The first is if this stuff seems new to you, then I'll encourage you to come at it from this perspective. Basically, think about how your application is interacting with the outside world. Now, that might be a database, it might be a cache, it might be whatever other services it's relying on. That outside world, sooner or later, will start to misbehave on you. Right? How does your application deal with that misbehavior? And could it be dealing with it better? And does it matter? I mean, this is a lot of mucking around. Maybe you don't care. Your database goes down, the application goes down, fine. But you should be thinking about it and thinking about what the best trade-off and choice is for your application. If you decide that you could be doing that better, try to think about how you can simulate those failures under controlled conditions. And this sort of thing seems like something that you're interested in doing. Come hack with us on it. Like, as I said, this is part of our kind of organic process for building applications that don't fall down. We're still learning, we're still trying new things, and we're still building new things. The vision that we're trying to work towards with these hosted front ends and various tools that allow you to interact with them in real time is kind of a CI or a Travis or a Jenkins for stress testing. Right, so that you can have a setup where your application is always ready to be stress tested, always ready to figure out how it's going to respond to failures. So if that sounds exciting to you, get in touch with me. Come and get in touch with the other guys at Mozilla who are working on this stuff, and we'll keep driving forward to try and make that happen. There is one more thing I want to talk about, and that's FunkLoad. You may have heard me on several occasions, if you've been to a few of my talks, express my dissatisfaction with FunkLoad and its API. It gets the job done. Like, it's not a bad tool, but it has a lot of rough edges. It's kind of hard to do all of the things that we want to do with it. So going forward at Mozilla, FunkLoad out, loads in. Loads is a new tool that we're working on to be kind of a better FunkLoad. Easier to write tests. So you want to write tests? You just use a requests library. Right? Everybody uses the request library for making requests. We'll use that for writing our tests. And Loads will instrument that to figure out all the things it needs to know. It's much better at getting a lot more concurrency out of a single machine than FunkLoad has been. It's much better at telling you about what's going on and when. So one of the things we want to do is generate real-time graphs of the output of your stress test as it's in motion. FunkLoad is not particularly well suited for that, so we're building a new thing to make it happen. It's not ready yet, but it's chugging along, and there are people being paid to work on this. Unfortunately, I don't think it's French for anything, so we're kind of ruining the theme. So thank you. A particular thank you to my colleagues, Tarek and Alexei, who are kind of the guys really driving these tools. James is our long-suffering QA guy for the services team, and he makes sure they're actually using these things and that they're actually breaking stuff. And he has a remarkable talent for causing things to break when you think they're fine. If you're interested in any more on these tools, these are the docs, or email me here. And I guess I have some time for questions. So thank you very much.
We have two microphones. Please queue at the base of the stairs, whichever one's closest to you, and we've got several minutes for questions.
I just had a question. So you talked about proxying particular protocols using Vaurien. Could you use this to front anything that you haven't already actually written proxying stuff for? So just a generic TCP proxy.
By default, it will just be a TCP proxy.
Okay.
I think the way that works currently is not terribly elegant because it expects you to be kind of request reply, but that there shouldn't be too hard to make it do something more clever there. So the idea is that by default it will just talk TCP. And you ask it for an error, it will just write gibberish into your TCP stream. And then if you want to get a little bit more particular about the kinds of errors you're likely to see, then you can implement a specific protocol.
Yeah, okay.
Yeah. So MySQL lost connection to the database error. Put that in at a separate layer. The idea is that you can write those as plugins and enable them in your configuration.
So something specific that you haven't got, like Postgres.
Yeah. So you'd probably still get a lot of mileage out of just standing that up and asking for delays and errors and stuff. Yeah.
Cool. Thanks.
Hey, as always, your talk was awesome. Last year it was great, and this year it was even better.
Thanks.
What I was thinking, so we have a RESTful API where I work, and we have a lot of different requests coming in, like I guess most APIs do. Sometimes zip files, sometimes other stuff. And I was wondering if there was a tool that we could use to basically, I don't know, capture all of, like, a production workload and then replay that back into one of these test tools, because to construct the amount of kind of variability of data that we need to actively do a load test, because all of our endpoints are different, being able to do that would mean that we could just, write out a 5 gigabyte file somewhere and then replay that back in under extreme load.
Yeah. I have a vague feeling that I've seen something like that before, but I can't remember what it is. Right. So I might go home and have a look for it. That sounds fantastic.
Yeah.
And it feeds into a question we had in this room earlier about, right, I want to do some load testing. Where do I start? What sort of load do I generate? What parameters do I need? And if you're in the position where you have a system and you have, some production data, to be able to just capture that and replay it as part of a load test would be awesome. If that tool does not exist, I want to help you build it.
Yeah.
So
well, because given that Vaurien, I wonder if you could plug into the Vaurien proxy and just go, for the next hour, just dump everything to a file and then somehow reload that back in.
That needs to exist.
Yeah,
you're quite right.
I think it's a great idea.
Yeah.
Damn it.
Sorry. So with FunkLoad, the last time I used it, and I assume it hasn't changed, these workers, they're synchronous and they can get backed up, and you can't actually rely on getting a certain hit rate on your server. So then the actual hit rate becomes a metric that you're measuring, rather than actually trying to recreate a certain request rate that you would expect in the future, given certain expectations. Do you think it's actually important to, does that matter? Should you actually be aiming to create a realistic, as far as you can gather, which is that question as well. Should that be something that you're aiming for, is actually getting a certain, realistic request rate on your server, and then extrapolating that, and then taking measurements from that, how your server handles under those loads? Or is the actual metric of the response rate of the hit rate fine?
That's an exceptional question, and I think there's probably 3 or 4 different answers in there that I want to give, so I'll try and unpack it as best I can. You're right about FunkLoad, and that's one of the reasons why we started loads, is that it's not always clear whether you're testing the limits of your server or your client, generating a level of load. So what I didn't show in this talk was the server-side monitoring. And if you're doing a load test, you really should have metrics set up on your server to see what sort of load you're actually generating, rather than listening to what your client-side tool is telling you, because that can be interfered with by overloading the client itself. I think the notion of getting a realistic kind of load profile on your server is very important. Certainly for Firefox Sync, we've had outages where it's just the server can't handle this load because the clients are posting bodies that are much bigger than we thought. So our load test, was not indicative of the kind of loads that we would have in production. At the same time, there's still a lot of value in just thumping, I'll get thousands of requests per second on this server and just thump it and see what happens. So I think there's 2 kind of different modes of testing in there that ideally you would be doing both of them. One of them more carefully to try and measure exactly how your system's going to stand up, and the other more experimentally, just to see what happens.
Yeah, exactly. Throw everything at it and just see what happens.
Yeah.
We'll make this next one the last question, please.
All right. Okay, great talk. Vaurien seems really interesting. I work with a protocol that's asynchronous. and I was wondering how it would lend itself to introducing errors in an asynchronous protocol where I would like to delay the responses or not return responses, send responses back in that asynchronous manner.
Probably not super well currently, but I'd like it to do that. So, I mean, you can write a plugin that does whatever you like. In the kind of base protocol implementation in Vaurien is just, here's a thing that has a callback that gets called whenever there's data. There's a little select loop that says, right, this socket's ready to send to this socket, do whatever you want to do with it. Most of the current implementations are very request response oriented. So you could probably implement what you want, but you might have to dig down a little bit deeper.
All right, I'll have a look. Thanks.
But yeah, it definitely should be made to make that easier.
Ryan, in appreciation, we'd like to give you a packet of the special Norwegian Blue blend of coffee for this convention, and of course a PyCon Australia coffee mug to drink it from. Everyone thank Ryan Kelly.
Thank you.